Good morning. My name is Chorchaba from พระปฐมวิทยาลัย School. Today, we would like to present mathematical application in linear programming. For the topic that we will present are 5 parts. Part 1, Introduction and Motivation. We talk about mean of linear programming, advantage of linear programming, and example. Part 2, solving linear programming. We talk about 3 methods to solve in linear programming. Consists of graphical method, simplex method, and computer software. Part 3, training experience and benefit. Part 4, future work, and Part 5, reference. Nowadays, there are competitions substantially in business, investment, service, and other industries. Each company needs to maximize profit or minimize cost under limited resources. That problem is called optimization problem. What is linear programming? A linear programming is an optimization problem for which we do the following. 1. We attempt to maximize or minimize a linear function of the decision variable. The function that is to be maximized or minimized is called objective function. 2. The value of the decision variable must satisfy a set of constraints. Each constraint must be a linear equation or linear inequality. 3. A sign restriction is associated with each variable. Xi must be either non-negative or unrealistic in size. For advantage of linear programming, as follows: to manage limited resources for maximum benefit, to apply linear programming to solve real-life problems, to reduce the cost in some business. There are some examples in the case. In the past year, we studied 2 examples consist of Sally et al. 2017 applied linear programming to reduce the cost of transporting water. Later 2018 applied linear programming to reduce the cost of construction site. This is example linear programming problem. Ready make produce both interior and exterior paint from 2 raw materials M1 and M2. Interior paint maximum demand per day is equal to 2 tons. Also, interior paint daily demand cannot exceed by 1 ton than exterior paint. Ready make want to get optimal product mix from exterior and interior product that increase daily profit. The following table provides the basic data of the problem. From the problem, first we formulate the linear programming model. We replace x1 equal tons produced daily of exterior paint, x2 equal tons produced daily of interior paint. Objective function, see the profit line. We get max equal 5x1 plus 4x2. Raw material M1, we get 6x1 plus 4x2 less than or equal to 24. Raw material M2, we get x1 plus 2x2 less than or equal to 6. Market limit x2 minus x1 less than or equal 1. Demand limit x2 less than or equal to x1 and x2 more than or equal 0. When we get the model of linear programming, so conduct solving linear programming. First method is graphical method. Graph of constraints including non-negative restriction. Solution space consists of infinity of feasible points. Then identify feasible corner points of the solution space. Candidates for the optimum solution are given by a finite number of corner points. Last, use the objective function to determine the optimum corner point from among all the candidates. From the model, we use constraint to write the graph as follows: blue area, pink area, orange area, red area, and green area, and the overlap area will be the feasible region. When we have a feasible region, we replace point A 0 and 0 in the objective function we get z equals 0 point B we get z equals 20 point C we get z equals 21 point D we get z equals 17 point E we get z equals 13 point F we get z equals 4 we see that point C is optimal solution an objective function with passed optimal solution point can be written in this linear equation line. Second method is simplex method. Simplex method is a solution to the problem can be used with two or more variables. Step 1 we convert the linear programming to standard form. Step 2 we obtain a basic feasible solution from the standard form. Step 3 determine whether the current basic feasible solution is optimal. Step 4 if the current basic feasible solution is not optimal, then determine which non-basic variable should become a basic variable and which basic variable should become a non-basic variable to find a new basic feasible solution with a better objective function value. And step 5 use the concept of elementary row operation to find the new basic feasible solution with the better objective function value and go back to step 3. We have the model. Next, we add x3, x4, x5, x6 to the model we call standard form. Next, we create simplex initial table. And next, we solve row operation and we get simplex final table. Simplex final decision, we get x1 equal 3, x2 equal 1.5, and z equal 21. And the last method is computer software. Computer software is a solution to the problem by using a computer program to help. Code program in R. The first line is package, which is requirement to solve linear programming in R. The next line gives the number of decision variable, and the next line input max or min depend on the objective function, and the next line is coefficient in objective function. Add constraint is coefficient in constraint, and the other line are the same as the first constraint line. So LPS model to check the model, get objective and get variable. When we run the program, we get z equal 21, x1 equal 3, and x2 equal 1.5. Training experience and benefit. We have studied linear programming, which is a method to solve optimization problem. We can practice solving linear programming model. We obtain a good opportunity to learn and exchange mathematical concepts with the expert instructor. Obtain the knowledge in linear programming which apply mathematical method to solve problems in the real world. And we apply knowledge in linear programming to do the project in the future. Future work, we apply linear programming to reduce cost and make more profit in business or investment problem. Reference. Acknowledgement. Thank you IPST, DPST พัชรีสำริดนรพงษ์ from ศิลปากร University Miss ปรารถนาวิริยะธรรมเจริญ from พระปฐมวิทยาลัย School. Thank you for your attention.